Do that again.
Start right over.
Just do it again.
The whole thing? No.
Summarize.
So it is my pleasure to once again introduce Ann Renninger. And so Ann's work has been in learner interest and motivation in a variety of contexts, in a variety of domains. She's worked in math and science. She's worked with children's play. And she's just a tremendously interesting and interested person, and it's my pleasure to have her talk with us at the Brown Bag.
Thanks. So now, as I understand it, I'm to say hi and then turn this thing off?
Yeah. Run all the way to the right.
All right. Take this way. Sorry, thanks. That's okay. Oh, that. Okay. Okay. All right. So, and I don't need to stand in the center. I'm good. So, welcome. Let's see. Just to get things started, I'm going to read you the title of this talk. It's Observating Things. It's not a typo. This is actually from a middle school age student who was talking about what it was that he was doing in science. Participant motivation and learning in an out-of-school science workshop. As Drew said, I actually have worked in a lot of different contexts. I've studied writing and reading and physics and computer science and math. Often what I do is to partner with practitioners or educators who have questions about what it is that they're doing, and I ground then my work with them, okay, in the practice and the practical questions, and then use that information to inform theory and subsequent research or research practices. So I do what's called use-informed research. Stokes had talked about that at one point. That's sort of taking what we know about the research literature and using it to inform the way that we address questions of practice. There's another way that this kind of work has been talked about as engaged research, and in the context that I'm going to be reporting on today, that's a particularly apt description, partly because I'm working together with Swarthmore College faculty and instructors who have developed an out-of-school science workshop. It's inquiry-informed, facilitated inquiry science. There are 4 levels of it. And it was developed for a group of children, it's middle school age, 10 to 12-year-olds. I don't know if you call them children exactly, but it's that middle school age cohort who are members of a children's choir that's held at Swarthmore. So the way that the context is set up is that the director of the choir actually goes into Chester, which is, in terms of school districts, the 501st school district out of 501 school districts in the state of Pennsylvania. It's really challenged, and at the time that we started this work, they actually offered no science to their students. So they were doing sort of reading and, I don't know, some version of math, but there was no science actually offered in the curriculum, which was appalling to my faculty colleagues. And it was partly because Swarthmore is a sort of small environment. I'd worked a lot with some of the science faculty, and they decided that I could actually figure out whether the students were, or participants in this workshop, were actually doing any learning or not. And so my students and I sort of set about trying to figure out, like, how would you evaluate this? And so the way that it works is that the children are selected because the choir director goes around to all of the second grade classrooms in the city and picks off the children who actually have good voices and, by playing music games could, obviously be trained in some way, does amazing things with them. They develop an ability to write their own music, do Gregorian chants, sing Bach. Arias in Italian. It's just amazing what he's able to accomplish. But the faculty at Swarthmore decided that the children also needed to have some science. And so this is where this particular study comes in. And it's one that I think has a sort of provocative piece to it, right? It's turning out to be quite successful. But it's an out-of-school science opportunity. Typically, out-of-school science is something that people want to do. you know, they've elected to go to the robotics camp. Right? This is not a group of kids who have any choice. Okay, they're assigned to go be in a science environment, but they haven't done much science before. All right, so back to the title, Observating Things. We're looking at motivation and learning in this out-of-school science workshop, and I want to acknowledge the funding from Howard Hughes Medical Institute. These are use-informed studies of economically challenged urban African-American youth who are 10 to 12 years of age, and it's the entry-level inquiry-informed out-of-school science workshops on which I'm really focused, okay? We've been focusing on these workshops for the last 10 years just to give you a sense of the depth of the data, but I can also tell you that the workshops don't typically have more than 14 to 20 kids in them, sometimes as few as 8. So it depends on sort of who's coming into the program, at what level they are, and what we have been asking questions about at the time. The partnership, and this makes it engaged work research, is that I'm working directly with the instructors and professors who are trying to provide the workshop content and are facilitating the workshops, and my students and I are gathering data and then feeding it back to the instructors and professors in order to enable them to continue to retool what it is that they're doing. And the goal is to support the children, people to learn. The assessment of participant interest in learning of science is what we have focused on specifically. And as Drew mentioned, most of my work has been in interest. So I study interest and motivation more generally across a wide variety of contexts. And when I'm looking at interest, I'm always interested in sort of the kind of learning that's going on. However, learning is not necessarily assessed in the same way in all contexts, as you probably all well know. So I'm going to tell you a little bit about interest and tell you a little bit about how we're talking about science learning, and then I'm going to actually talk a little bit about the studies and open it up to questions. So interest, when I talk about interest and study it, I'm really talking about the psychological state during engagement, the interest experience, if you will, okay, and the predisposition to re-engage that kind of participation over time. So I'm not simply talking about, does somebody like something, do they not? I'm actually talking about the quality of their engagement and the likelihood that they'll come back to it over time. You know, if you're trying to support somebody to learn something, what you really want is that kind of re-engagement so that in fact that they will actually continue to learn. And so when I think about what the components of interest are, I'm talking about knowledge as well as corresponding value and feelings. Suzanne Heedy and I developed a model of interest development based on existing research about 10 years ago now. And what we did was to identify that there were a lot of people who were studying interest, but they were really studying it sort of at different places along the trajectory of interest development. And I just throw this up here so that you can actually think about interest can be triggered, and often in the science classroom, there's an explosion. Everybody's paying attention, right? So that's a triggered interest. Whether that's actually sustained, that's the key question, okay? And understanding how it can be sustained and supported to develop is what's critical to thinking about supporting students to learn, and interest as a possible indicator that some kind of learning has gone on. So for purposes of the experiment that I'll be talking about today, I'm going to actually really just talk about earlier and then later phases of interest. Whoa, and it still works. All right, the indicators, so if I go back, the indicators for the earlier and later phases, or for these individual phases, are sort of how frequently does a person re-engage the content? You know, with what kind of depth are they engaging? Are they doing it voluntarily? So in other words, do they do something with science outside of the time that they're being sort of forced to be in this workshop? They're not. I have to tell you, they love it, and it's not about being forced, okay? But, and then will they actually do it independently? So there's something about, you know, doing something because other people are doing it, and it's quite a different thing to elect in your own free time to take on doing something. Liking, as I said, is likely to be present, but it does not distinguish between phases of interest. So if we go back and look at this, what happens is that you can actually like you know, your interest is triggered, you could actually like what you think you're going to learn, right? But you can also really like something if you have a really developed interest in it. So it's not a really good way to distinguish between earlier and later phases of interest. And one of the things that I've been particularly interested in, I'm not the only one, but that I've been interested in thinking about interest development is how do you support interest to develop? Now, just 2 minutes on this and then we'll keep moving. What we know from affective neuroscience at this point is that interest is actually associated with the reward circuitry. What that means is that when interest is triggered, it activates the reward circuitry, right? The reason that that makes a difference is that it leads to information seeking. That's the way the neuroscience community talks about it. Information seeking is essentially what interest is about. So the reason that you want to trigger interest is because, and then have it sustained, is because then the person actually will take on their own information search. They'll ask questions, they'll follow through, they'll persevere when things are difficult. All of those attributes are what you need for somebody who's going to continue to engage in content in a meaningful way. The trick is that the initial triggering of interest does not guarantee that it will be sustained, right? And that's where we as educators come in. And the idea is, how do you support a person to make a connection? What I would say is to the content. So it's to the actual science, not to feeling good about themselves in the situation. It's good, you know, it's always nice to feel that you can do something, but you actually need to make a connection to the content as well, right? So these are the indicators of interest that I'm talking about. And what I can tell you is that, you know, interest at this point, and this is in the research literature on it, has been identified as having a reciprocal relation. This is not reciprocal in the math sense, but what it means is that with respect to goals, for example, a person who's only got a little bit of interest isn't really in a position to set goals for themselves. They're not able to feel self-efficacious. They're not likely to be able to self-regulate, and they certainly don't identify as a scientist. Whereas somebody who has a well-developed interest is able to set goals, is likely to feel self-efficacious, is able to self-regulate in order to do something more, and is probably identifying as a scientist. What I can tell you also, though, is that each of these variables are sort of distinct variables so that they don't all work exactly the same way. It's not like a slam dunk. You get them to develop interest and you get all these things, but you know, they will evolve over time, and there's pretty good evidence now that that can be expected. All right, so when I'm talking about learning, what I'm talking about is understanding and remembering, or what people are talking about as deeper learning, and not just learning of procedural information. I don't want to throw the procedural information out. You need it, but it's not sufficient. What we've been working with is Lehrer and Schobel's 3 approaches to science, and I recognize that some of you are science people and some of you aren't, but just sort of, if you can just hang in there with the science part of this, I think what you'll do is to get the gist of it, okay? So there are different ways that science has actually been described in the learning of science. And when we originally started these studies, I thought, well, okay, we're going to actually figure out like whatever we can say, okay, about science in this context. It wasn't clear to me whether we were going to be able to talk about science as theory change. So that's, you know, understanding sort of what science is, if you will, sort of what scientists do. Science as practice, so that has to do with classic experiments, and what we do in ours is to tell a story about a park in Chester, and we actually have the children actually figure out sort of what they think is going on in the story and to tell us what they think, or, you know, to generate hypotheses and talk about how they would test them in order to remedy the situation where the park is actually starting to die out and there are problems that need to be addressed. So that's the science as practice approach. And then there's science as formal logic. And that's where you actually have reasoning. You give some tasks to the children, and you're actually asking them to sort of know about controlling variables, basically, right? So it's, in other words, in this situation, how would you be able to tell that something else was or was not happening? And do they understand the idea of controlled experimentation? We mapped backwards, knowing that in working with instructors and professors who are helping to run these workshops, that this content was available in the workshop. So it's not like we're looking for something in our testing that isn't there. But there are pieces to the way that the children are able to connect to these different kinds of science learning that are informative to what I'll be telling you next. We also are looking now at the NGSS science practices, and these are pretty straight up. They haven't really been studied as a unit, but we're able to map them back to the classroom practices. And what we're also doing is trying to look at them in relation to change over time, looking at the interest of the children and also their learning. So what we've done is to study successive ways of participants. You might have caught this is a summer workshop. We run one of the entry-level workshops, or actually sometimes two, a summer. The children are all from the same neighborhood. It's the same workshop format. And what I'm reporting on has been the same curriculum and the same instructors. Okay, so we're trying to control the number of different variables going on here so that we can actually look at what it is that the children are able to do in the context, and what our intervention that we've developed with the teachers is how it's working. We also then use, from one year to the next, one group serves as a control for the next. So we're like doing different kinds of interventions the next summer. We can use what happened the year before as a kind of control group. And then we also will have a control group that is independent, but children who are in the choir but haven't yet done a science workshop. The data sources, so I'm going to report data sources 2 different times, but in our initial studies, just to give you a sense of this, we were doing interviews with science tasks inserted at 3 time points. And so examples of those 3 types of learning were inserted into the interviews. So we didn't do them as surveys. I wasn't absolutely sure that what we would get if we did sort of, you know, Likert type ratings with this group of kids. And, you know, their writing is actually sort of challenged. We do some writing work with them, but the interviews were a good way in. And so we took up interviews and we inserted these science tasks in order to be able to look at what was happening before the workshop started, what were they able to do at the end of the workshop, at the end of 5 weeks, and then what happened 5 weeks later? Were they actually able to retain the information? And actually at this point, we're now looking a year later. In our early, we also collect running records during the workshop. So these are sort of ethological running records on individual kids and the conversations that are going on, just to track what's going on. And, you know, we've added video in our more recent work. And in the early studies, we also did calls with parents and guardians. I don't know if you've ever collected this type of data, but with a challenged population, you know, these are kids who come to this workshop, or come to their summer session, you know, and somebody in the neighborhood's just been killed, or somebody, it's a truly challenged group of kids. They love the science, they're loving the music, and they love the program. So, there are many wonderful things about it. But in the early studies, we decided that we would also collect information from the parents and guardians at the beginning and at the end of the workshop and later, just in order to sort of like confirm that what we were getting is information about what the kids told us about whether they ever went to a museum or whether they were taking things home. Like, we just wanted to have some checks. Okay, and the fun story from this, and it actually really bears on the next piece of information, was that in our calls the first summer, what we learned was that the parents, okay, so we were interviewing the parents and guardians. Actually, it's a larger percentage of guardians than it is parents, actually, but whatever. Okay, what we learned was that we're interviewing them about, like, or the phone calls are about music, and they're also about science, partly because the parents and guardians think of this as a music camp. They don't actually really think of it as science, right? And so when we were talking to them, what we realized was they were only talking to us about science. We called and asked about music, and we would ask the same questions about science, and we kept hearing about all the experimentation, details about what it was that the kids had done, the dissection of the mink, so this, that, and the other, you know. And so in other words, the kids were going home and telling the parent guardians about what it was that they were doing. This is such nice support for the idea that the kids were getting something out of the experience. However, what we also learned was that the participants had a lot of fun, but they weren't evidencing much science learning when we looked at these tasks that actually were the sort of standard bearers in the literature. And so I reported this information to Howard Hughes, and he came back and said, I really appreciate your honesty. What are you going to do about it? Right? And so I'm sitting there going, you know, honestly, I'm only helping out on this project. I mean, how are we going to do this? But so what we did was to think about what might help us to better anchor what the kids were doing. You know, we knew that they were paying attention. We knew that they were gathering information, and they were really sort of bombing these tasks that we were giving them in terms of showing any change. In fact, it got worse. You know, what they were doing was telling us about everything. They wanted so much to answer the questions. They were giving us a lot of information. And even when we read through the answers to try to figure out what they were able to tell us, we were still not getting completely good stuff. And so what we realized was that there are multiple literatures that point to the need to support attention. Again, this comes from the science work, but there's really similar evidence in writing, and if you're interested in that, ask me questions later. So conceptual change, inquiry learning, the framing of pedagogical practices for transfer. What we know from these studies is that they either point to the role of interest in learning or interest as an outcome. So it's not that interest would have been the focus of the studies, but it's typically reported in some way. But what's not clear is how and when interest is supportive of learning, or how the tasks of the inquiry workshops might be adjusted to support attention to learning. And so that's what we decided that we would focus on. And what we did was to look at the literature. We sort of did a big search of different kinds of interventions. My idea here is that we wanted to piggyback on other literature. I see it as good scholarship to, you know, actually look at what other people have also done. But there was also a way in which here we were working with a very challenged population, knowing that they were able to learn something. But the question was how to support them to actually look like people with developed science capacity. And so what we did was we adapted something called the ICANN intervention. So that is being used by Daniel Shakontis, who does work in reading and also in mathematics. So it wasn't in science at all. And we've actually pretty radically changed it. But we like the ICANN, you know, the idea that there's like a self-efficacy piece to this. The kids actually talk about it as ICANNs. They talk about the ICANNs, and you'll see that these are statements. So what we basically did was to follow on the way that a lab works anyway. You know, if you think about what scientists do, they always have lab notebooks and they keep notes, right? And so the children actually all had lab notebooks. And so what we did was we stuck what we call ICANN statements into the lab notebooks. And so that meant that they would do their inquiry activity, and then they would actually respond to the ICANN statements. They're basically open-ended, ungraded, written reflection that we then code. And just to give you an example, in week 1, I can measure like a scientist, and you can see that the children actually were able to write. I mean, it's sometimes more articulate than not, but they are actually able to state what it was that they did. I measured a pea plant, right? And in week 3, you see that there's a little bit more information that's being provided. Okay, so these are going to become the general ICANN interventions. What we found was that the ICANN intervention, okay, and the reason for this, the sort of background rationale, it's an example of a self-related intervention, okay, because it directs the learner to connect to the self. So asking, by saying, I can explain something, actually supports the person to figure out what they can explain. And by not grading it, by just sort of seeing what they write, what we're actually finding is whatever it is that they connect to. I would say it's theoretically similar to a utility value intervention. And again, I don't know if you know this work, but this is actually really taken the sort of undergraduate, it's late high school, undergraduate student community in STEM sort of by storm, because what people have found is that by relatively simple interventions, you can have someone write about like why it's useful to learn biology, and that will actually up their performance and also develop their interest in the class that they're taking. That is, if in fact they have had no interest and they're very weak in what they're doing. And this is really very successful for underrepresented populations and people who have been challenged in some way in their learning. So what we're doing is developing an intervention that we wanted to work with both students who had interest and people who didn't, as well as with people that had more capacity or not. So it's a little bit different, but what we're doing is a similar kind of thing in that we're asking the student or the participant to actually make a connection to what they're learning. In the first studies, we showed that interest was supported to develop and that learning, and this is especially in terms of science's theory, could occur. And if we were to summarize it, you can see that science's theory changed. We were actually seeing that, and we didn't see it in either of the two control groups. We don't see it in science's practice and science's logical reasoning, which led us back to going and looking at what were the problems, you know, for the children in the way that they were engaging those tasks, so that we could also try to address them. So in the current study, what we've done is to take that general I can probe. I can tell you what I notice when I'm lifting the button out of the water, right? And we make it an evidence-based I can probe. Our thinking was that the children, when they were given that practice task, that science's practice task about the park in Chester where everything was dying and how they would handle it, they came up with everything, including the kitchen sink, to explain like what was going on there, right? So they weren't working with the evidence and the problem, they were actually pulling on everything else, right? And so this is very consistent with sort of one of the goals for the science practices in the NGSS, but it also sort of had leapt out at us as where the problem seemed to be. And it was a similar kind of problem for the logical reasoning. And so what we decided was, let's see if we can actually make these ICANs more evidence-based and support the learners to actually hang on to the need to have evidence, and as such, then deal with these tasks eventually building on evidence. So in this, you'll see that the additional piece to the ICAN probe is, I can tell you why I think that this happens. All right, I should also tell you that I don't know how many of you were teachers, but I was. For kids, you know, if you did this every day of their life, it would drive them nuts, you know, and it would become very routine and it wouldn't be fun anymore. So we actually do change it up, but we also don't do it every single time, right? So what we have is, we have evidence-based probes. We're also doing evidence-based work in the classroom, but what we're trying to do is to sort of do the amount that actually would be tolerable. The kids actually like doing the ICANs. This is not a hard thing to get them to write, but it's not like doing it every time. And we know that like there have been some people who actually even the second level of these workshops have tried to push it too hard, and it doesn't work. Okay, so it's complicated. It works better for the kids who have less interest, but not for the kids that have more interest to be sort of hit over the head with it. But there's no need to do that. What we do find is that the students who, or the children who actually respond to more I can probes, so in other words, it's open-ended, ungraded. Sometimes they respond to 1, sometimes they respond to 3. If they respond to more of them, they actually do better science learning. So we do know that like if you can encourage them to do more of them, that would be good. All right, so going on. So the participants in this study that I'm gonna sort of focus on here were a target group, a control group, and a second control group that had no workshop and no intervention. What we had as data sources were their responses to the ICAN probes, repeated interviews, much like the ones that I just described to you, video data as well as classroom level, at the classroom level, and then participant observation, where what we did was we really focused on 4 focal participants so that we would have deep information about them. All of the analyses are within person. In fact, that's really the way we've run all of the analyses for all of these studies. And we are looking here at interest as both a dependent and an independent variable. So what we wanted to know was, okay, if the kid comes in with less interest or more interest, what does that do, right? And then we also wanted to know what the relation of interest was, you know, like what's its effect in relation to a number of other variables. What I should also add is that these data are in the last 3 to 4 years, and one of the things that we've noticed over time is we think it's because of television programming that we now have kids coming into the workshop with some interest in science, right? Which 10 years ago we did not see, and I see that as sort of like neat. It doesn't mean that it's deep knowledge, but they're actually in a different way. They're primed in a different way, and it's actually sort of nice for us because we get to look at people that have more and people that have less interest as we're moving through our studies. All right, so what we found here was that when we use the evidence-based probes, we actually were able to show some substantial learning for the target group on all of the tasks, okay? And that feels to us like really important information. The control group, 1, was the group that I told you that we had studied before, so like in this, okay, and they had only had the sciences theory change. That doesn't mean that all of the elements of science practice or all of the elements of logical reasoning are addressed. There's still things that can be worked on and that we are working on, but they're mostly hitting it, and we're able to say they're working with the evidence in the problem, and that the evidence is actually supporting them to then respond to these questions in ways that would show or demonstrate that they have learned the science that they've been working with in this inquiry setting. So what we're also seeing is that there are increases in interest from time 1 to time 2 for both the general and the evidence-based IChem probes. If you study inquiry learning, or know much about that literature, inquiry typically will like raise kids' interest, right? Because it involves active learning, right? There's also been this gradation of types of inquiry environments, and facilitated inquiry is particularly useful for this population because it really supports the kids to engage meaningfully in the inquiry as opposed to just sort of like whatever goes. But I'm sorry? Oh, I thought there was a question. Okay, so what we're seeing is there are increases in interest, right? And we also know that the evidence-based IChem probes, that interest will be sustained till time 3. Okay, so that's also powerful. What we're thinking is that because the knowledge is deeper, because there's evidence-based information of it that they're working with, that actually enables the interest to then be carried over time, because the knowledge has deepened, and it's sort of, if you were to look at that figure I had, they're really developing their interest in some meaningful way. We're also finding that the analysis of their science practice skills indicate that both questioning and content knowledge develop first. That's before prediction, interpretation, and measurement. And our running records are indicating that as interest increases, the participants ask more sophisticated questions that in turn are also supporting their learning. So then when we look at interest as an independent variable, what we're seeing is that there are increases for those with less and more developed interest on the sciences theory change task, and for the general or evidence-based IChem probes. But we're also finding that high interest is different than low interest. However, we're seeing increases but no differences between those with less and those with more developed interest who receive the evidence-based IChem probes on sciences practice and sciences logical reasoning. So that means interest actually increases, and then it's almost like the presence of interest is enabling them to work with the evidence-based content. That's very powerful, right? Because you can develop interest, but what we don't know is that you definitely have learning happening at the same time, right? And when I was reporting to the Howard Hughes group, what we knew was that the kids were having fun, and we knew that they had learned something, but we actually couldn't put our finger on it. Other studies of inquiry have shown that inquiry will heighten interest, but it doesn't, we don't actually know for a fact that it's going to support learning to occur. And our own evidence is showing that you actually need to have something more going on. And that's where we think that the evidence-based probes are actually helping the children or the learners to focus on the science that we're supporting them to learn. So interest is supported to develop in the inquiry context and sustained over the year. Interest development accompanies the developments in questioning and the content knowledge. The I Can probes encourage reflection on inquiry, and we think are scaffolding attention. And we're also further suggesting then that task design can point to importance when people are not prepared to identify the particular content as important themselves, right? So if you think about this as, you know, kids going in and getting a task, and it doesn't really matter what kind of classroom we're talking about, they get a task to work on, right? But if they don't know what they're supposed to be focusing on in it, they'll attach to some other aspect of it. And what really needs to happen is enabling them to focus on what it is that you want them to learn in the task. And then the question is, how do you do that? You can always tell them, but generally, if you tell people, they don't do what you ask them to do. I mean, that's not like a real effective way to get someone to learn, to say to them, you need to do this, right? I mean, they'll do it, they'll nod their heads, whatever, right? But what you really want is to support them to see for themselves, right? And by enabling them to work with these evidence-based probes, what we're doing is supporting them to use evidence to inform their practice, so to speak, right? And to attend to the aspects of the task. So the interest enables them to engage with the task in what we think as sort of a more meaningful way. So moreover, the evidence-based attentional work appears to work similarly for those with less and those with more developed interest. That's really important. It provides a basis for interest development and for learning. Interest studied as both a dependent and an independent variable in relation to learning suggests then that there's a reciprocal relation between interest and developing content knowledge, right? So in other words, they're developing concurrently. And the more interest is developed, the more learning. However, regardless of the level of interest, the learning that occurs may be related to the presence of support for attentional focus, right? And this comes back to the real need to sort of guide. This is where the educator comes in. But what's also really interesting to me here is that, you know, when I was talking earlier about the neuroscience work, right, that would sort of suggest to you, look, what we need to do is trigger and somehow or another support kids to find, you know, the meaning and relevance to themselves so that they'll actually continue to develop interest, right? And it sounds like interest can continue to develop. But what we also know is interest will fall off if a person doesn't continue to be challenged, right? So it needs to be difficult enough. It needs to be challenging within range. And what we need is to support the learner to continue to develop their interest. And that's where, you know, understanding the role of attentional focus in relation to learning ends up being a powerful way to enable science interest, for example, to continue to develop. I think of you as doing literacy studies, so, you know, it also would be interest in writing or interest in reading. And that piece about how it is that we as educators can enable the learner to sort of continue to develop their interest and really continue to engage in information seeking, I think is like the key to being able to be effective as a educator. So that's the end of what I have prepared, but I'm glad to answer questions. Yeah, Eli.
So, like when you talk about these IPN interventions as like these attentional help with attention, it makes it sound like it's sort of a preparation for future learning content, sort of like helps them think about how to engage in some future activity more productively. But I guess when I think of like the holding and sustaining, I think of something, I guess I'm wondering about the timing of the interventions, and does it matter so one way is to think about it as like a preparation activity, but what about like a reflective activity? And are you thinking about where you place the interventions so that they have this effect, so that they sort of test your theory about in what way they're useful?
So Eli's asking a question. I'm supposed to restate this just so you know.
Okay. Yeah.
It's not like I have to. Okay, but in any case, okay, so Eli's asking a question about sort of when the participants receive the intervention and whether or not that makes a difference in terms of the holding and sustaining of interest. But actually, I may not have been clear, but the children are actually receiving IChem probes every day. So every day in the workshop is inquiry-based content, right? And they're receiving IChem intervention probes in their lab notebooks every day that are getting them to reflect on what it was that they did during that workshop, right? And the whole idea is that the probes are supporting that, or statements are getting them to reflect back on what they've been doing. And so by having them come through and have to work with evidence, right, what we're trying to do is to support them to have that become part of their practice, right? So that it's a little bit rehearsal maybe, but it's in the context of what they've been learning. And they're asked this probe that actually then says, and how do you know this, right? That gets them to pay attention again to what it is they know, rather than just pulling in whatever it is that happened to drift into their head. And then that supports them to sort of have that as a way of engaging other content. And we're seeing that on the second and the third. You know, it's actually being held over time. The way they approach these sciences practice and sciences logical reasoning tasks. Does that make it more clear?
Yeah, I
Okay.
just wondering if I just.
Yeah.
So you think it has both, like so it's used as a reflective thing.
Right.
So maybe it helps them rehearse.
Well, I think you could actually say that practice working with evidence, right? So it wasn't that they weren't getting evidence-based work in the context of doing this inquiry, but I think of it as like this morass of stuff, right? And they weren't able to cut through it. And so that these IChem interventions, they're getting 2 or 3 probes a day, right? Are getting them, or supporting them to actually stop and say, okay, so what do we do in that fun activity? And how can, and when I'm asked about it, and how do I know that I know that, right? So, does that answer? Okay, so there is a rehearsal piece to it because they're getting some practice doing it, but it's really getting them to slow down. So again, I don't know how many of you have worked in inquiry-based environments. They're wonderful, like everything is going at once, right? But the problem is that kids can get so swept up in it, and I mean, Bruner wrote about the importance of being able to reflect on what it is that you're doing, right? Stopping and really stepping back and thinking about it. Here we've got kids who have never seen a scalpel before, and they're being allowed to do a dissection. And, there was the first time I watched this stuff in process, I thought, this is like complete lunacy. Like, how are we going to ever measure the learning and motivation of this population of kids? But it really is, very rich, and they will stop. And scientists do need to take notes. And the kids actually talk about this. They talk about it when we're interviewing them, how they go back to their IChems they talk about it that way. I go back to my IChems in order to find out what I did before, which is exactly what a lab notebook is about, right? So these are sort of an organic insert that in a way seems to be really helping them out. But I don't have a need for you to march out of here and say, oh, and we have to do IChem interventions. I think it's more about the attentional focus. And the question is, how do you support kids to actually attend to what it is that they need to in whatever the task is that you presented them. So there were other questions. Yeah.
I have 2 unrelated questions.
Well, we can do 2, 1 and then 2. Okay.
The first one is just, well, thank you for your presentation. This is very generative. This is what I'm working on right now.
Good.
But I work with adults, and I'm wondering if the theoretical frameworks of interest and learning that you used are, equally applicable with adults.
They are. I actually have also studied teachers and professional development, for example. It's very interesting. I mean, the big problem is that you can't really ask a math teacher if they have a developed interest, because you know what? As a person who has that role, they're never going to tell you that they don't, right? Okay, but you can actually do things. Those indicators that I read off to you actually are very revealing. Does the person do anything with math outside? Are they participating in, some of the blogs that are out there on math? What kind of math resources do they seek out? How do they use them? How much adjusting of things are they doing for their class from the textbook they use? Those things are great indicators of how developed an interest is. So Suzanne Hedy and I have a book that was just out last year. It's called The Power of Interest for Motivation and Engagement. If you send me an email, I can send you a flyer and that you can get it cheaper. The pricing on these things is crazy. Or you might be able to get it like through your interlibrary loan. But the idea was that it was written for people that didn't actually come from the motivation field necessarily, but there are endnotes that will point you to the literature. So yeah, I think definitely for adults too.
Okay, and thank you, and I'm very interested in looking at the book. My second question is kind of unrelated to that. I mean, it seems very clear to me that there's a very positive cycle of interest in learning, and that the attentional scaffolds kind of help to cement the learning part of that once interest is in play. Can you talk a little bit about self-efficacy and how that fits into that?
Sure.
Those relationships.
Sure, we're actually studying that, and I wish, I actually had a slide, and then I decided, well, the data are not firm. I can tell you, I mean, actually in this study, let me answer one more thing for that other question, okay? And that's that interest can be supported to develop at any age. So people know that you can develop it much later, right? So it's not about like you were born with a certain predisposition when it comes through, okay? And also in any context. So even if you think you hate math, we could work on you, right? So just connect. All right, so going back to the other question that you're asking. Actually, you know what? I just lost it. Self-efficacy. Okay, right. So what we see is that the kids are, so this last cohort, it was motivation and learning, and I decided that, well, anyway, so interest, we know, will actually shoot up and actually basically be sustained. It drops just a little once the kids are out of the workshop, but it's not a significant drop, right? And we actually see it being held through. What we see with self-efficacy in this workshop is that it actually drops. So the kids come in and they respond to questions like, about like, how effective they are in science, or you don't use that word, but like, how good are you at science? What do you think? And we're using some of the Eccles work on self-efficacy. I don't know if you know that. Okay. Anyway, we're using these questions. But what we find is that by the end of the workshop, that drops, right? And so it's really interesting. It's almost like a diamond that you're seeing. So interest is going up, self-efficacy is going down. And then what we find is that by the next year, that it's actually kind of like when they start the workshop again, it's sort of like it comes back up again. And what we think is going on there is that the kids are actually excited about science when they start out, right? And they feel like they can do it. And then they learn how much there is to know about science and all the possibilities. And so that there is a dip that happens that then actually leads to a kind of increase as they re-engage and feel more confident in what they're doing. And so we're just trying to replicate that. So what I mentioned at the very beginning about small samples, yeah, I think you need to be really clear. But Herb Marsh, who does a lot of work on self-concept, actually describes a similar kind of dip in his work, that self-efficacy often goes down before it goes up. And so when I talked about the different variables that sort of with development actually become more aligned with the developed interest, self-efficacy is one of them. It's just that self-efficacy is about your belief, right? Your belief that you can do a task, which is different than interest, which is really about the way that you're participating. It's about the state, that excitement kind of stuff, as well as the likely re-engagement. And it may or may not be something you're reflectively aware about. So you don't really ask the person, I mean, you could, but you don't say, you know, are you interested in this? You could ask an adult maybe, but not a kid, right? But what, you know, tracking their behaviors, using behaviors as your indicators might be a safer bet. Does that answer your question?
It does. I mean, the study I'm working on has a really different set of conditions. It's
Okay.
adult, very low level readers,
Mm-hmm.
many of whom have very low interest, and the particular intervention is very skills based. So as they develop a sense of self-efficacy, they develop skills, give them a greater self-efficacy,
And then
they
interest.
develop interest,
Yeah.
and then they
So
do
it-
it more, and then that helps to develop their skills. So I'm seeing that like very anecdotally, and I'm wondering if that's sort of
No, and actually that would be very consistent. So, yes, and they do work that way, that, you know, one feeds the other. So I think especially with a group of adults who are low, it's really hard to not be able to read. Okay, other questions? Yeah, Jared.
So, so first, I really love the cycle of the way in which the interest feeds back into the activities and change of activities.
Right.
I think that's just beautiful. I also like your 4-stage model of development of interest. And I was focusing on the first stage, you know, where the interest is occurring in the context of the activity, relatively new perhaps,
Right.
and looking at it as a state. And what's coming to my mind is there are several words that are used in literature, perhaps overlapping meanings, that describe that state of interest, or have to do with it. You know, one is the goal, one is the arousal, one is the engagement, one, you know, there's the attention, and is interest an aggregate of these things? In that state of being interested, in your understanding of it, is that an aggregate of having a goal and having an aroused attention and being engaged, or is it an additional thing to that?
I think it's an aggregate. Okay, so I think that that's what people are figuring out, right? So there are several different ways to describe interest. So people have described it as an emotion, right? Or they've talked about it as values, right? And I think that when you talk about different phases of interest development, you see different configurations of value. It turns out that emotion actually holds pretty constant within person. You know, so a woman named Mary Ainley, she's in Australia, has studied that. You know, and so it turns out that like when you have less interest and more interest, you, the individual, your emotional state will actually be relatively similar. Isn't that interesting? I mean, people actually think of, you know, you have interest, it's heightened, you're much more excited, right? But in fact, it's not much more excited than I would normally be excited, right?
So your concept of interest as a state of interest is an aggregate of
well, it includes
several
arousal,
goals,
right.
arousal, intensity, certain.
All of those can be identified in the experience or state of interest, right?
Okay.
That's right, right. Yeah, I mean, I think the goals is the part that's a little, well, the goal is a little complicated though, because of the unreflective piece of it, right? So somebody, especially if they have low interest, so if we go back to this woman's low interest readers, right? They have no idea that they could possibly develop an interest in something, right? It's the last thing. Like they're going to do it because they have to. And that's where these utility value interventions are very positive, you know, that often by supporting people to find that it's useful, that's, I would say, a trigger for interest.
Because the initial goal is simply compliance with.
It could be, right. I mean, she's changing her head, shaking her head. We could have a large conversation. Let me see if somebody else has a question now. Is there anybody else with a question? Or yeah, Drew.
Yeah. So we've got, you know, you have this attentional focus, but then you do have these I can questions that are supposed, you know, designed to increase motivation. Have you done studies where you kind of take you still have, because these attentional focus questions, I mean, have been core to lots of, you know, key questions within disciplinary studies, right? So is the I can move the thing that's changing things, or like if you had worked with kids and gave them the attentional focus, let's focus on evidence, but you didn't have those I can motivation moves, would you expect different kinds of results?
Well, so the first studies we did didn't have the I can in it, right? And what we saw was that they were having fun and they were sort of all over the place. And so that was when we developed, sort of adapted this I can approach so that we would have something that was sort of scientifically appropriate and enabled the kids to pay attention to the context. There may be another question on what you're asking, which is, are there other things going on? We tried to control. This is naturally occurring. I have to tell you, every once in a while, the instructors have some other brainstorm, like in the middle of class, and like, who am I to like comment on that? But I do have to track it because it sort of changes your experimental condition. But one of the things we have noticed is that, for example, if you're, so they sit in groups of 4, right? And if your group of 4 includes one other person who has more interest, and it's a social group that actually works together, interest actually seems to move a little bit differently, okay? So we're also studying that at this point, right? Which is sort of what, does it matter if you're at the lab table with 2 other people who you don't really talk to and don't share your interest in science, or people that are, right? So, that kind of thing, but that's not really your question. I can tell by your face, yeah.
Well, but is it the self-efficacy move that's really driving this, or are there other paths? Are there suites of ways of enhancing this interest? So even the idea that you've got groups, it suggests that
we're just sort of looking at that to see like what's going on there, because it sort of does look like it makes a difference for this age group. And again, you've got middle school kids, and the social interest is actually big. So that sort of makes sense that somebody without an interest in science could come in, sit at a table, start seeing things, and it actually, so it intensifies it, but it doesn't mean that interest didn't develop for everybody else in the inquiry class. I think attentional focus is really critical. I'm not sure that it's only critical for self-efficacy though, okay? So, what we see is, and actually we discuss this in this book too, we talk about what the coordination of motivational variables looks like over time. So, different people have studied sort of what the relationship is to goals, to goal setting, or being able to self-regulate. You're much more able to self-regulate. If we wanted to talk about grit, okay, I'm sure that you're all familiar with sort of that notion, right? That's sort of like just pushing through, right? If you have interest, you don't have to push through. I mean, it puts you into just a very different space. And one of the things I should point out about grit in relation to interest, and I've talked to Angela about this, so it's not like Angela Duckworth, so it's not like this is, I'm talking like in a different space. But the thing that's interesting is that for the most part, when she's studying grit and it's really successful, it's people who were really quite accomplished violinists and want to be virtuoso. It's like it's the last piece that really pushes you over the really developed interest piece of it, right? So it's very different to talk about supporting grit in a elementary school context, whereas it's relatively easy to support a kid to develop interest. I mean, surprisingly, especially if you think about earlier and later phases, and you realize that earlier a person needs to make a connection. They need to connect themselves to the content they're learning, whereas later in the development of interest, they already have made that connection. So they don't need that, but they need to continue to grow their content. They need to be challenged. And support, again, to do the attentional piece that will get them to the task in a meaningful way is really what's critical. I can see you're ready to finish. Okay, so thanks.
So thank you, Anne. And one quick before applause, don't forget the DeMarzo lecture is tomorrow. I hope you all join over at Gloucester School at 3:30. So
okay, great.
Thank you.
Did I answer?
Yeah. I mean, it's interesting, because Plato in good teaching is always like, what's the core question, right? So, and then, so what's the trigger beyond just this question?
We know it's the content needs to be developed in order for it to develop. But we also need the content to develop